Hello. Thank you for joining this Neurology Live peer exchange, Understanding Spinal Muscular Atrophy, SMA, and Recent Advances in Management. Spinal muscular atrophy describes a group of disorders associated with spinal motor neuron loss. The age when symptoms begin correlates with the degree to which motor function is affected. Early age of onset has a greater impact on motor function. In this Neurology Live peer exchange discussion today, I'm joined by a panel of colleagues, all experts in the field of spinal muscular atrophy. Together we'll discuss the diagnosis, management, as well as use of new therapeutic options and those on the horizon, and provide a practical perspective on how the recent data can apply to your clinical practice. I'm Dr. Nancy Kuntz, a pediatric neurologist at Ann and Robert H. Lurie Children's Hospital of Chicago in Chicago, Illinois. Participating today with me are our distinguished panel. Dr. Claudia Chiriboga, Professor of Neurology and Pediatrics at Columbia University Medical Center in New York, New York. Dr. Basil Darras, Director of the Neuromuscular Center and Spinal Muscular Atrophy Program at Boston Children's Hospital in Boston, Massachusetts. And Dr. Elizabeth Kachula, Assistant Professor of Neurology at Children's Hospital of Philadelphia in Philadelphia, Pennsylvania. Thank you all so much for joining us. Well, let's talk about spinal muscular atrophy. Today we are really going to focus on the most prevalent type of spinal muscular atrophy, which is genetically associated with a homozygous deletion of exon 7 in the chromosome 5q-. There are other rarer forms, but they have different etiologies, and they're really not part of the very exciting new translational science that has led to treatments. Perhaps the first place to begin would be to talk a bit about the prevalence and incidence of spinal muscular atrophy. Maybe you can comment, Daryl.
SMA is a rare disease with an incidence of about 1 in 10,000, which means that 1 in every 10,000 babies who are born may develop SMA. Looking at the distribution of SMA, as you know, there are different types, and there are different percentages assigned to each one of the types of SMA, but the prevalence, let's say, for the most severe form of SMA is not as high as the incidence, because many of these babies, they used to die in the past without any intervention. As far as the carrier frequency, it's pretty high. 1 in every 50,000 people, 1 in every 50 individuals are carriers of the SMA mutation. As far as the genetics of SMA is concerned, the gene for SMA has been mapped to chromosome 5q in the early 90s, and it was 1985 when the gene for SMA, known as the survival motor neuron gene, was discovered by a group of researchers in Paris. And what we learned is that patients who have SMA, they have what we call a homozygous deletion of the SMN1 gene. That's about 95% of the patients. And the other 5%, they are compound heterozygotes, which means that they have a deletion on one chromosome, they have a point mutation on the other.
How does that affect the ability to detect the spinal muscular atrophy with testing?
Yeah, it does not have a major impact because, as I said, 95% of the patients have a homozygous deletion. So we start by doing the deletion testing, and we usually detect that. And it's only in very rare situations where we have a child who looks like SMA, and we do the testing, and the result comes back as being a carrier, in which case we need to do further testing to identify the second mutation. I talked about SMN1 gene, which means that we have another one which is known as SMN2, again on the long arm of chromosome 5. The SMN2 gene is the reason for why humans develop SMA, because without SMN protein, the fetus can never make it to the term of the pregnancy, and we have what we call an embryonic lethal situation. So, so again, humans develop SMA because we have the second backup gene, which differs from SMN1 by a small number of nucleotides, but one of them is very crucial because it does alter the splicing of the gene in a negative way, meaning that one of the exons, known as exon 7, is not included during the splicing, and for that reason, we end up with the production of protein which is not functional. It's only functional about 10% of the time.